This celestial body has captured the curiosity of scientists, not only because of its impressive size and position within the solar system, but also due to the unusual lights observed on its surface lights that appear to be artificial in origin. Could we be on the brink of uncovering discoveries that might revolutionize our understanding of the universe? Might these lights suggest the presence of life beyond Earth? By examining the remarkable findings from NASA's exploration, we may soon gain valuable insight into these puzzling phenomena. In 2007, NASA launched the Dawn spacecraft with the aim of studying some of the most compelling bodies within our solar system. Powered by 3 ion engines, Dawn began its journey by conducting a 14-month observation of Vesta, the second largest asteroid in the asteroid belt. It transmitted high-resolution images and comprehensive data that unveiled Vesta's intricate surface features and geological diversity. Thanks to the unique capabilities of its ion propulsion system, Dawn was able to exit Vesta's orbit and set a course toward Ceres, something that conventional chemical propulsion systems could not have accomplished. These ion engines delivered continuous low-thrust acceleration, enabling the spacecraft to traverse vast distances and enter a stable orbit around Ceres. Ceres was discovered in 1801 by Italian astronomer Giuseppe Piazzi and is the largest object within the asteroid belt situated between Mars and Jupiter. Once regarded as the smallest recognized dwarf planet in our solar system, it received its reclassification in 2006. With a diameter of roughly 950 kilometers, Ceres not only dominates the asteroid belt in size and mass, but it also stands out for its unique features. Scientists eagerly awaited detailed imagery of this enigmatic world, which eventually revealed bright spots scattered across its surface, most notably within a large crater named Akator.
These luminous regions immediately intrigued scientists and sparked a wave of speculation. Prior to Dawn's arrival, our clearest view of Ceres came from a low-resolution image captured by the Hubble Space Telescope, offering limited information. The opportunity to observe Ceres up close brought with it the promise of groundbreaking discoveries. One of Dawn's central objectives was to enhance our knowledge of solar system formation and the influence of water in the development of planetary bodies. The bright spots seen on Ceres and on other asteroids as well were believed to consist of highly reflective materials, possibly salt deposits left behind by evaporating water. These findings hinted at the possibility of cryovolcanism, a process by which icy volcanoes release liquid water or briny substances instead of molten rock. This raised compelling questions. What are these strange lights? Do they indicate ongoing geological processes, or could they point to something even more extraordinary? After a 2-year journey through space, Dawn began its final approach to Ceres in early 2015, an important milestone that offered the first close-up views of this vast object. As Dawn drew nearer, the surface of Ceres came into clearer focus, revealing a terrain marked by numerous craters, evidence of a long history of impacts. However, the mysterious bright spots within this dark, rocky landscape drew the greatest attention from scientists and observers alike. As the image resolution improved, researchers proposed several theories to explain these luminous patches. Could they be reflective ice catching the sunlight, or were they evidence of something more unusual? Hypotheses ranged from mineral accumulations to indicators of cryovolcanic activity. Surprisingly, closer analysis showed that the brightest area was not a single light source, but a collection of several individual spots. The prevailing theory suggested that these were salt deposits, possibly remnants from the sublimation of subsurface, briny water. Ceres is particularly notable for its chemical makeup. Its outer layer contains water, ice, and hydrated minerals such as clays and carbonates, which give it a lower density compared to other asteroids. These materials suggest that a significant amount of water is present. The surface is rocky yet porous, with trapped volatiles that make Ceres resemble a comet more than a traditional asteroid. Its interior is thought to include a muddy mantle encasing a core rich in water ice, which accounts for nearly half of its total volume. The planet's internal structure likely consists of a briny rock mantle surrounding a denser core made up of silicates. The presence of so much water ice supports the theory that Ceres may once have had liquid water, possibly sustained by heat from radioactive decay in its early history. This composition sets Ceres apart from its neighboring asteroids and raises fascinating questions about its geological history and the role of water in its development. An especially intriguing discovery was the presence of ammonia-bearing clays on Ceres. These materials imply that the dwarf planet may have formed in the colder regions of the solar system and later migrated inward. Ammonia has the property of lowering water's freezing point, which would support the existence of brine at or near the surface. These insights not only deepen our understanding of Ceres itself, but also provide clues about the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, a rare and relatively little understood geological phenomenon, is believed to be active on Ceres. Unlike the lava-spewing volcanoes on Earth, cryovolcanoes, sometimes called ice volcanoes, release water, ammonia, or methane in liquid or gaseous forms. Under the extreme cold of space, this material rapidly sublimates, transitions directly from solid or liquid to gas when it reaches the surface, leaving behind bright reflective salt deposits. These salt residues are believed to be the cause of the bright spots observed on Ceres' surface, particularly within a crater. This region, designated as Region 5 by researchers, has drawn attention for its high reflectivity and for periodic hazes recorded by dawn, which are thought to be the result of water sublimation. These findings suggest that cryovolcanic activity may still be occurring or has happened quite recently on the dwarf planet. Beyond Decatur, Ceres hosts several other bright spots, each with unique features. These luminous areas are not confined to one region but are spread across the surface, implying that cryovolcanism could be widespread. This challenges earlier beliefs that Ceres was geologically dormant, instead painting a picture of an active, evolving world. As dawn continued to send back high-resolution images, more varied and complex features of Ceres' surface came into view. The terrain is dotted with craters, each offering clues about the planet's history and evolution. These detailed observations have reshaped our understanding of this enigmatic dwarf planet and its potential to hold secrets about the formation of the solar system and perhaps even the ingredients necessary for life.